This lecture covers the preparation of alkynes. Alkynes can be prepared from dihalides using successive dehydrohalogenations. In order to do two dehydrohalogenations, you need a very strong base, such as sodium amide, you need two equivalents of the base, and you need a polar aprotic solvent to increase the basicity of that base. In this case, we are starting with a vicinal dihalide. That means that the chlorides are on adjacent atoms. And if we were to draw out the mechanism, we'll see that it goes through an E2 mechanism. So starting from our vicinal dihalide, we have our base, which is sodium amide, attack one of the protons, and kick out the chloride leaving group. This gives us our intermediate, which is the alkene. Our second equivalent of base then comes in and does the second dehydrohalogenation to form our final product, the alkyne. Each of these steps follows an E2 mechanism. Instead of a vicinal dihalide, we can also use a geminal dihalide, and that's when your halides are on the same carbon. Again, you'll always need a strong base. You need two equivalents of that base, and you will go through the intermediate alkene. So drawing out the mechanism, again, you're doing two successive E2 reactions, where you start with deprotonating with your strong base, and this forms the alkene. Your second equivalent of base then does the second step, again an E2, to get to your final product, which is your alkyne. And again, this is an E2 mechanism, this is also an E2 mechanism. Now let's predict the products for this reaction. We've got a geminal dihalide, and we have two equivalents of a very strong base, sodium amide. We have to make sure that we do have protons to abstract, and we do. So overall, we can imagine that the first equivalent of base will abstract this proton and kick out the bromine. The second equivalent will abstract the second proton and kick out the chloride. Overall, you would have gone through the alkene and reached the alkyne. So the final product will be this alkyne. Now let's look at the second reaction. If we have to predict the product for this reaction, we can see that we've got two equivalents of sodium amide and we've got a vicinal dihalide. We need to look at what the possible products are, and if we think about eliminating this bromine, we'll see that there are two possible beta hydrogens, one on this carbon and one on this carbon, and each proton will give us a different product. In order to determine the final alkyne, we need to look at the intermediate alkenes and decide which one would be favored. If we were to choose this proton in red, the product that we would get is going to be a terminal alkene. And if we were to choose this proton in blue, the product that we would get would be the internal alkene. Using Zaitsev rule, we know that this one would be favored because it's more substituted and more stable, and so this would be the intermediate alkene formed, and then we would do the next dehydrohalogenation with this proton to eliminate this bromine. And so our final product is going to be the internal alkyne, and we figured that out by assessing which alkene was more likely to form.